graphical mode. At least I showed you the screen, right? A non-graphical mode, you would only get to see the command prompt. Everything you have to run commands and execute it. Whereas the graphical mode is user-friendly. So like your Windows system, you would be pretty much familiar with the desktop, where to log in, where to check the applications and all. Okay. The same way, the installation process which is there, it also has a graphical method and a non-graphical method. That means in non-graphical method, for example, if I have chosen only 512 MB of RAM, the installation would still continue, but you may not be able to see the screen. So this is a graphical installation process. There is also non-graphical installation process. Before the process begins, the system will say that you don't have enough memory. That's why proceeding with the non-graphical installation process. Okay, so don't get confused that if you don't see the screen, the installation is not proceeding further. So in non-graphical installation process, rather than choosing doing click, you would have to type the inputs. Okay, so that is the only difference. Okay, now here another important thing with the VM box, okay, Oracle virtualization box. If you're closely following my screen, I'm going to keep the cursor in the middle, and if I click, okay, the cursor goes inside. Okay, and there is a right click. So as it says at the bottom, okay, keypad, there is a control button on the right side. Two control buttons are there, one on the left, another one on the right. So if you press the right control button, then you will be able to bring the mouse outside, cursor outside. All right. So the first option, English, United States. This is common. Proceed. So we would be choosing the language and then choosing the keyboard type. Ramesh, can you hear me?
Can hear you.
I think some people are not on mute. I can hear a lot of sounds. So if you don't mind, can you keep all the participants on mute?
Sure.
All right, everyone. So two pages where we have chosen. So that's pretty much. Then comes this main section. So here, whatever you see, right? So date and time, keyboard, language support. Okay. So once this is done, then comes the software. So this is the source. That means the ISO file that we have already chosen, right? So then comes software selection. So we'll get to this section in a while. And installation destination, and the option chosen by default is automatic partitioning selected. Now regarding this, so we'll be using this word called partitions in Linux system, which is similar to drives in a Windows system. In Windows we say C drive, D drive, F drive, okay? But in Linux system we call them as partitions. So it is going to be the partitions where the software will be further split and all the files will be distributed. Then is the network and host name. So network and host name is all about setting up your host name and choosing the process, choosing the way in which you want to have the IP address set up to your system. Either you set a fixed IP address, or you prefer to go with a dynamic IP address selection process. That means if you're connected to an ISP service provider, okay, and if you choose a dynamic IP selection process, that means basically your system will request for an IP address from the nearest DHCP server. Okay, so there are two ways of assigning IP address. Manually you assign an IP address, or you prefer the other way where your system would act as a client. It will search for the nearest DHCP server. That would be your ISP. You will be connected to a router, right? So the router further will be connected to the ISP service provider, who will give you an IP address. So that we'll see in a way. So we have chosen these three. Installation source is our ISO file. Now let us come to software selection. Software selection process has uh, a few set of groups, I would say. That means uh, if you remember the list of packages that I showed you yesterday, all right, that means I have showed two links. One link contain the ISO file. ISO is like an image, okay, and another link I showed you all the files which are part of the ISO file. Among those list of files, there is one folder called packages. Inside that folder, I showed you all the RPM packages. Okay, I said there will be around 4,000 RPM packages as a part of your operating system. So here there are some groups created: KDE Plasma Workshops, desktop, server with GUI, virtualization. So each of the group would be associated with a set of packages. So it's not like you will be installing all the 4,000. So if you wanted to perform a minimal installation of Linux operating system, if you choose this, some of those packages would be installed. If you want to do if you want to make your Linux system as infrastructure server, then some of those packages will be taken, and accordingly your system will be prepared. Okay, so that is what all these different groups are. So initially, so So when you are learning about the Linux operating system and we go through all the different topics, gradually you will be familiar with most of these topics which you see in the right side. Okay, so initially you need not have to worry about choosing the packages. So it is sufficient if you just stick to any of this. Say for example, a desktop version. Okay, or you can even go with the minimal installation. Just click on done. Here if you observe, it says checking sys. So checking software dependencies means now you have chosen one group. Okay, say for example that group corresponds to 10 RPM packages. Okay, so those RPM packages that we have seen yesterday, each package in turn will have dependency packages. That means even in Windows you might have observed it, when you are installing something, it would say that this corresponding library file is missing, you need to install that first and then proceed with the installation process. Okay, the same concept is applicable for Linux also. So when you have chosen a group which corresponds to 10 packages, so these 10 packages in turn are dependent on some other compilers or some other library files. Okay, so that is what happens here. So previously we have seen a message, right, that it is trying to pull the dependency packages. So now it has pulled all. So along with those 10 packages, it will pull the dependencies, say for example 10 more. Okay, now it has made uh, its process ready, that it has kept all the 20 packages ready that needs to be installed in order to complete the OS installation process. So that is what was happening. So I would suggest you to watch every message that comes on the screen. So So it will give you some information on how the system works or how the installation process happens. So you would get to know, you would have a better understanding of the internals of the system. All right. So next comes the partitioning. So by default, if you don't choose any of the options, right, whatever that you see on the screen, and if you just click proceed, still the installation process would complete. It will go with the minimal installation process. It will go with automatic partitioning method. Automatic partitioning is where it will choose its own. So this is, it will have its own default layout. Okay, that will be present. It will perform that. But rather, we will go with customized partitioning process where we select configure partitioning. Now, I have here, if you observe, it says that my hard disk is 15 GB free. Okay, so this is where I have chosen the hard disk. Okay, so that means the virtual box container that I've created it and I've allocated around 15 GB. So that is what is displayed here. Okay.
Is that the setting what you kept, Sharon? You said you are taking 20 GB, right?
I said choose around 50 to 20 GB. This is anyhow I'm going to close. I'm not going to use this.
No,
So
no,
I'll
no. My
just put
question
over
is
here.
whatever we assign that is going to show up there, right?
Right. For the virtual container, so whatever we allocate 15 GB or 20 GB, if you have allocated 20 GB, that is displayed here. 20
Got it.
GB,
Okay.
that acts as the operating system hard disk.
Got it.
And another important thing, so is how the operating system has identified your disk. You can see it says SDA. Okay, so if you're familiar with the types of hard disks, we have SATA hard disks, we have IDE hard disks. Okay, there are two categories. So SATA hard disk usually is identified as SDA. So now rather than using the word hard disk, I would simply say that SDA is our hard disk. Okay, now inside SDA there will be comparing with Windows, we create C drive, D drive, E drive. Similarly, here we will be creating partitions. They are called as SDA1, SDA2, SDA3, like that. That is the convention we will follow.
And what is the second type? Hold on, Sharon. What is the second type did you say?
The second type is IDE hard drives. So if you are using an IDE drive, it will identify itself as HDA.
So what is
Then
the IDE?
partitions would be, no, it depends on the type of the disk. We have only two categories. Okay, we do not have to go deep into the uh, functionalities of the types of drives, but SDA drives are considered faster, so you would mostly be finding SDA drives only.
Sure. Can you show me the section where there is network disk? Little bit. I just don't want to waste time. Can you show me
Like,
on the add a disk on the specialized and network disk below? Yeah.
okay, this one.
Yeah.
We don't have any network-based devices now, so that's why you may not find the option to configure here. If at all there is a network-based device we have, then we can choose it from here itself and then proceed with the installation process.
Got it. So it would show like a network path and you have to select that part.
Correct, correct.
Got it. Thank you.
Okay, now we have chosen the customized process. Click OK. Okay, so I've said automated installation process. So even if we don't choose the option, the system would continue with the installation process, right? So what happens is in that process, your partitions will be created, and the process used by default is LVM. Okay, we have LVMs in the later modules. This concept LVM means logical volume manager. Okay, so there are different types of partitions present. We have primary partitions, we have external, and there is also a concept called LVM partitions. So with LVM partitions, once you create LVM partitions, so there are a lot of additional features flexibility of extending. That means increasing the size of the partition, decreasing the size of the partition, correlate it to C drive in size, and then it is running out of space. The size of it is some 30 GB or 40 GB like that. So those features are available with LVM, but for now we will stick to the standard partition type. Okay. So when we reach LVM concepts, then we'll see how to create LVM based partitions. So all the options that we are following now, that means in terms of setting up the host name and network, choosing the packages, okay, installing the packages, creating partitions, all these things would again get repeated post the installation process also. That means we will also create this partition after the installation process. We will also install software after the installation process. So now I am creating the partitions. So in Linux system, uh, the way in which the file system is organized, okay, is uh, please listen this carefully. So in Windows, so the topmost folder is what? My computer, right? So that is max you can go. Choose any folder in the system. If you click on the previous folder, it goes till my computer. That is the topmost point where you can reach. Under that, you have C drive, D drive, and again you go into each of these directories, right? So if you look at the system this way, so the topmost point, my computer, under that C D drive, under C again all the program files, whatever you have. So it depends on how you have done the installation. If you have kept all the operating system related files in C drive, then free space would be in D drive, and inside the D drive you will have all the other information that you will be using it in your computer. Similarly, in a Linux system, the topmost point is called as root folder, okay, or forward slash, okay. In Windows, we usually use backward slash notation in order to separate the directories. That means in the command prompt, if you want to go to a specific folder, you say cd space C drive backward slash uh, program files backward slash, like that you travel into each of the subfolders, right? Whereas in Linux it is quite opposite. So we use forward slash in order to move from one folder to another folder. So the forward slash acts as a folder separator, and at the same the topmost reference point. Okay, so under topmost forward slash folder, not like Windows where we have only C or D drive, we have multiple folders present. Under forward slash, I repeat, or the root folder, we have multiple folders present. Okay, so I'll explain about each of these folders in some time, the importance of each of these folders. Whereas among all these folders, there is one folder called as boot. Okay, the boot folder contains, so I'll be using the word called directory instead of folder from now, because directory is the terminology for Linux system. So under the boot directory, we have all the bootable files present. That means, so booting itself is the process in which Linux operating system starts. Okay, all the files which are associated with the booting process are the bootable files, and they are present under the folder called as boot. It is recommended that we create a separate partition for boot folder. Clear? So forward slash, as I said, is the topmost point in Linux system, the root folder, and we have the boot folder where all the bootable files are present. Okay, so we will be choosing boot folder. So this boot folder would contain all the operating system files, like all the Windows operating system files are mostly are in C drive, right? So similarly, so here we are going to split all the files. We are categorizing them. So all the files related to system booting are forward slash, and the capacity. So boot folder, if you are using CentOS 7 or Red Hat 7, okay, the files which are going to be under the boot folder, they would be of a maximum size of 100 MB in size. Okay, so there are other requirements also. That means other files which would come into the boot folder. So I would suggest that you allocate maximum of 500 MB to the boot folder. So it can vary between 300 MB to 500 MB. Okay, so I'm just choosing 500 MB. Now you need to click on add mount. Now if you ask me what is add mount point, okay, so this mount point topic is also very important. Okay, a small example, say you have a pen drive or a USB drive. Okay, you connect that to your laptop. So what happens now? So your system will identify pen drive as some drive, right? It opens a pop-up saying that it has identified an external drive connected to your system. It says some F or G drive, and it will open a box inside which you will get to see the contents of your pen drive, right? So what happens here is your USB disk is a drive, okay, and your system has allocated a mount point, okay, or it is called as access point. So that access point name is F drive. So that F is linked to the USB disk that you have connected to the system. There is a link that has been made, and using the F folder you can access the contents of the external disk. That process is called as mounting in Linux. So we are creating a partition called as SDA1. So that is not shown here, but SDA1 is a partition on your hard disk. That partition is linked to an access point called as /boot. Clear? So always the concept is your physical disk which is there, that is linked to an access point, a virtual access point like a C drive or a D drive, so that users can click on C and connect to your physical drive. Okay. Similarly here, /boot is an access point to access the separate partition that contains all the bootable files. So this is called as mount point also. Done. So I've created a boot folder first. So like that we'll be creating 3 partitions. So that is the recommended process. So click again /. So for boot we've created a separate partition. So / means rest of all the file system is connected to, is linked to /. Okay. So I said 15 GB of disk space I have chosen, 500 MB I have allocated to the boot folder, and out of the remaining 14.5, say I would choose 13 GB for my /. It's totally up to you. Just you can leave 2 to 5 GB of free space so that you can make use of it for creating partitions in the later topics. Add a mount point. Okay, let me choose 12. Done. And plus, then comes swap. Now I hope you all are familiar with the importance of RAM in a Linux system. So whatever applications you use, whatever operations that you perform, okay, so all these things basically they go into your RAM. Okay, so your RAM will keep getting filled in. Okay, so RAM basically helps you in order to make your system faster. Okay, rather than going to disk and fetching the content, it is much faster to fetch the content from your RAM. Okay, again to go one level deep, on your hard disk basically, uh, the pointer has to travel across the disk in order to fetch the data. So if you're requesting for some the data which is distributed on your hard disk, okay, in order to fetch the data, it has to go from one location to another location and fetch it, whereas it is not distributed that way in your RAM. That way it is much faster to fetch it from the RAM. So the reason why I'm talking about this topic is, so as your RAM gets filled, say for example your system has less amount of RAM, so when your RAM gets filled, okay, so the performance will become, the performance is impacted, the system will be slow. So we create a partition called as swap partition. So for the swap partition we allocate some space which is part of your hard disk only. Okay, users do not touch the swap partition, it is mainly created for system purpose. Okay, so we do not uh, go to the swap folder and all, that doesn't happen. We only create a swap partition and leave it like that. So the reason we create it is, as RAM gets filled in with a lot of pages that we access. Okay, so if we create a swap partition, so as the RAM gets filled, what happens is the system will try to move some of these pages from your RAM to the swap space. Okay, then it will create some room so that it will bring some more new pages to your RAM. So this way the system performance will improve. So that is why we create a swap partition. Okay, so usually if you have 2 to 4 GB of RAM, it is more than sufficient when you work on your Linux system. Okay, so this concept is applicable when there is a higher load on your system, higher load, or you're performing or you're using a lot of applications in your system. So keeping that in mind, we have this concept of creating swap partitions. But if you have plenty of RAM available, there are applications where people use 100 GB or 200 GB of RAM itself. Okay, so if you have so much huge amounts of RAM, swap partition, even if you create, it may not be used. Okay, so just remember, as long as you have plenty of RAM available, swap is not needed, but it is one of the topics that you have to learn. And the recommendation is to use twice the size of your RAM. Okay, so if I have for this system I have allocated 1 GB of RAM, so recommended disk capacity is 2 GB. Okay, but even if you use 1 GB, it's not a problem. Even if you don't create swap partition, it is not a problem, but we will be learning this concept. Clear? So I'll stick to 2 GB as per the recommendation, twice the size of RAM. Done. So these are the 3 partitions that you have to create. Now here we'll just go through some of the additional options. The first one is / boot partition. Okay, among the different file systems that are present, we will be choosing ext4 file system, similar to NTFS or FAT file system that you see in Windows. In Linux, we have different types of file systems. I would suggest that you stick to ext4. The same file system is applicable for / also. The root partition, choose ext4. Whereas for the swap, as I've said, it is not for system users. The file system name is also swap. Okay, so it is used as a functionality is similar to how the RAM is used. It would also be used like that. So these are the 3 partitions that you have to create. If you want, we can also create additional partitions that is totally dependent on the use case. Okay, and even here this is a recommendation. You can simply select / only / and proceed with the installation process. Okay, you might find some installations done in that way also. It's like doing the complete Windows installation in your C drive. So now it is saying that it will perform the format the operating system and start the installation process. Click accept. Now we'll proceed to network and hostname. Okay. Now coming to the hostname part. So by the time we reach working on topics like remote connectivity, alright, configuring servers. So I would suggest that you have 2 virtual machines available in order to practice, because so these topics, right, we can make one instance as server, another instance as a client, or say for example if we want to copy files from one Linux machine to another Linux machine, there you need two instances, right? So so gradually we'll create 2 or more instances. We'll see how to make connectivity in between these 2 instances, how to create a small network among these instances. Okay, so right from the beginning what we do is so we follow some, you know, it's like a kind of a recommendation you can consider. Okay, so usually in order to create a small network, we need to keep all these machines under a common domain. We need to keep these machines under a common IP address range, like that. Okay, so keeping that in mind, so I usually prefer uh, to follow a convention with respect to the host names. For example, this particular host name, I would say so Red Hat 6, host 6 dot, excuse me, host 6.7vm.com. So serenvm.com is like a common domain that we'll use across the other machines. So usually if you take a complete fully qualified domain name, okay, so in that there will be a host part and the rest will be the domain part. So here host 6 actually is this particular host, and serenvm.com is like a domain that I will follow across my network. That means if I create another instance, I would name it as host7.serenvm.com, like that. Okay, then you can click on configure. IPv4 settings. So IP address, okay, I hope you are familiar with the IP addressing system. We have 2 different types, IPv4 and IPv6. Since we are close to making use of all the available IP addresses in this world, that means the range, the total range, it has 4 octets. So 0.0.0.0.02, it goes till 255.255.255.255. So each octet has 256 places, which is 2 to the power of 8. So totally 2 to the power of 8 dot 2 to the power of 8 dot 2 to the power of 8 dot 2 to the power of 8. So again, if you go with all the permutations of how many IP addresses, there are like some thousands or in millions it would come. Okay, so this is the only range that is available across the world. So this again is further split into different classes, like class A, B, C, D, E. That means, so these classes are like say for example 0.0.0.0 to uh, 10.0.0.0. So all the possible combinations belong to one class. Okay, so this may not be the exact range whatever I said, but you can refer to those ranges. So these 5 classes are defined. I think the last class is the range that has been left over for doing the research. Okay, and then there are some private ranges defined. That means these private ranges you can use for the personal networks or for domestic use. So you for your private network you can use those ranges. They are 192 network is one, 192.168. So I usually follow this, or you can also go to 10 dot network. These are two private networks. Okay, so another range is allocated for research, and another one is class A and class B are, I think, for public use. That means public use means if you are connected to an ISP service provider, the IP address that you get is a public IP address. Okay, so that is brief about IPv4, and then comes we also have IPv6. So people have started using IPv6 also, where you would have 8 octets present. In fact, it is a hexadecimal number. So we'll see IPv6 addressing system later. Okay, so with IPv4, as I've said, we have different ways. One is manually assigning the IP address. Another one is making your system as a DHCP client. So we'll stick to the manual addressing system, because with DHCP there is nothing much that you have to do. Choose DHCP, that's it. Your system will fetch the IP and it will start working. But we want to know what IP address is, how to assign it, so we'll stick to the manual process. Okay, so the manual address, as I've said, it is 192.168. So rest of the 2 octets you can choose your network. What I prefer is I use 1 dot. Okay, 1 dot, then we have 0 to 255. 1 dot 255 is a broadcast address that we don't use for the system. That means I don't set an IP address of 1.255 for my system, because that I use it for broadcast purpose. So choose a number in the range 2 to 254. 1.1 is automatically assigned to my router. Okay, so I have an internet connection. That router will have an IP address of 1.1. So you are left with 2 to 254. You can choose in this range. So I will stick to one number, 135 for example. Then comes the network mask. Net mask means or called as subnet mask. So it has already identified itself as 24. So 24, or it can also be represented as 255.255.255.0. Okay, 888. So that is 255. So this subnet mask, the importance of the subnet mask is the IP address that you have chosen, right? So this IP address again can be split into two pieces. One part represents the network, which is 192.168.1. That is the network. So why I have split in this way? I mean, the first 3 octets why I have separated, because the subnet is 255.255.255.0. So first 3 are filled. So that's why I have split the first 3, and the next one is the actual identification of my computer. Clear? So that is how, I mean, this is simplest example for subnet mask. We can still go into the complex, but it's totally a networking topic. Okay, so with the help of subnet mask, it is possible to identify your system in your network. Usually this concept is used in order to create subnetworks. So if you have a big network of, for example, 190 to 168 range, so what we can do is by creating a subnet mask, with the help of a subnet mask, we can create subnetworks in such a way that each subnetwork is isolated. Clear? So that is the importance of subnet. That's why we use it. So there is a concept altogether called as subnetting. So using subnetting concept, we create a lot of smaller isolated subnetworks in a bigger network. So then comes gateway. As I said, my router will be the gateway. So that is where I'll be connecting to. So done, save. I hope you all have heard about the network adapter which is there in your system. So it is the adapter using which you will get an identity in your network. Okay, so this IP address is assigned to the network adapter only. So that network adapter, okay, it's almost like a service. So by default, the network service will not start by default in your Linux system. So even if I have chosen the manual process, when I start my computer, by the time I complete the installation process, it will not get started automatically. It starts only when we choose DHCP as option. So we have to manually start the network service post the installation. Then only the IP address will be taken. Okay. So it's just not connected because we have chosen the manual process. So with this, we are almost done with the installation process. Clear? So feel free to interrupt me. You can ask me questions at any time. So I'll start the installation process now. So here you can see the installation is getting started. Please observe here, it's the /dev SDA, that is our root partition, and it will also show other partition related information here, like we have chosen boot / and swap partition. So here it is trying to create these partitions with the file system. So boot will be the first partition, that means SDA1. Root will be the second partition, SDA2. So apart from, okay, so here parallelly this keeps on going, creating partitions, performing the installation. Okay, so we have two more options here: root password, user creation. An admin account has all the privileges in a Windows system, right? Similarly, here it is called as root. So don't get confused. The same word will be used for a root user, okay, who is the administrator in a Linux system. The same word I have used for the topmost point, that is, I said /, right? And root user also has a home directory that is named as root. Okay, so different ways in which the word root is used. So root user is the only admin account. You cannot change or you cannot delete it. Okay, so the root user, we need to set the password. So other than the root user, we have non-root users. As a root user, you need to be very careful when working on a system, because the operations that you perform, like if you have deleted an important file, then you cannot revert those changes. Okay, so now I'm going to select the root account password. As I said, other than root, we have all the non-root users present in the system. That means we have to create them. So for non-root user, it is possible to give root access. Okay, you cannot always rely on a single root user in the system, right? So you should be able to give some advanced level of permissions to other users depending upon the requirements. If you are part of an organization, so you cannot just give the root password to everyone, even if they are part of the admin team. So for that we have a different concept. We will go through that, but a part of the installation process. We do have the option. If you want, you can choose this and make the other user, that means non-root user, as an administrator. So the root account, we'll be learning everything using the root account only, okay, during the installation, I mean throughout the course. But an actual scenario, okay, so root account is rarely used. That means usually non-root users will be given admin privileges, so you try to switch to that user and perform or do some setup, okay. So rarely we switch to actual root user and perform the operations. So all these privileges which are there, they are further categorized, like all the user creation or creation of groups and all. So privileges related to these features are given to one user. Privileges related to disk management, they are given to another user, or privileges regarding installation of the software, they're given to a different user. So we can split and give the privileges accordingly to non-root users. So in an actual scenario, that's how things work, okay. So here we do have the option, but I'm disabling it so that I can show you the distinction between a root account and a non-root account. So choose anything here. That's it. Okay, so we are done with choosing all the options. Now the system will continue and it will perform the installation process. So once the installation process is done, we will get to see the command prompt. I mean, sorry, the login prompt. Well, you can see there are 1238 packages that have been chosen. So it will take some time in order to complete the installation process. So we will proceed with the other topics, okay, and leave it like that. Well, here so this is my CentOS 6 instance that I showed you yesterday, okay. So in a virtual box, it is not possible to copy paste any files from your Windows system to a Linux system, okay. So if you want to have that functionality, so there is this client called as Putty, P-U-T-T-Y, okay. You can download this. I mean, mostly the organizations make use of such client tools. So one is Putty. There are some commercial tools as well, like Tetia. Okay. So Putty is open source. You can download Putty. So using the Putty, so this is a client. Using this, I'm connecting to this machine. Okay, to CentOS 6, I have connected using this client. Okay. We just have to give the IP address and username password to Putty to connect to the other instance. So using Putty, I can click, I can right click, choose all the options. Okay. Okay, just give me a second. Okay, so this is how it looks like. So here, check your IP address. It is 125. So come here and enter. So one is Putty, using which you connect to your Linux instance, and there is another software called WinSCP, WINSCP. So using WinSCP, you can copy files from Windows system to a Linux system and vice versa. Okay, so these two tools are mostly used along with Linux machine. So in case if you want to try something, copy something from uh, Windows to Linux and vice versa. Okay, so one is PuTTY, another one is WinSCP. Just you can make a note of these two tools. So I've just logged here. So as I've said, I'm not making use of it. Okay, so let's proceed with. Yeah, wanted to mention is different type of installation. So one differentiation I said, right, graphical and non-graphical. So another category is about the type of installation that you do. Excuse me. So among the type of installations we have manual installation and automated installation. Okay, it is also said like attended installation process, unattended installation process. So manual installation is where, I mean, the process we followed now, it is called as manual installation process, where you choose each of these options, and now we will wait until the installation process is over. Another process is automated installation process, or a network-based installation process. It is also called as the kickstart installation process. Okay, so kickstart installation process is where we give instructions to the system to perform the installation. Okay, that means in order to do the installation, okay, just generally think like what does the system need. So we have the operating system disk available with us, or the ISO file is available with us, right? And other, so we have only used the ISO file, and then we have uh, given some instructions like regarding the language, keyboard. That is the additional information that we have provided to the system, right? So these are only the two things. So what we can do is post the installation process. Okay, options that we have given to the system, they are created. Okay, they are copied and installed to a file. So that is called as anaconda-ks.cfg. Okay, so we have chosen the root user. I have logged into the system as a root account, and in my root home directory, so this file is created and kept by default. So if I open this file, see kickstart file automatically generated by Anaconda. So here, if we go through the options, it says install CD-ROM, so that's the ISO file. So this is the language that we have chosen, keyboard, and the network. So when I've done this system installation, I've chosen 1.25 as my IP address. So as I said, 24 is also represented as 255.255.0. This is my gateway. Clear? And this was the system. I have host name that I've given. So if you want to go with a network-based installation, then don't choose the host name, because the same host name will be given to all the systems. So yeah, another important point. So this file, as you see, right, so it has the list of all the instructions. So what happens is, when I go with a network-based installation, I would simply say that I would simply say this to the system, that all the instructions, the kickstart file is present at this location, okay, and then all the operating system files are present in this location, that is the ISO file. So I would tell the system to follow the instructions as a part of the kickstart file and perform installation using the software. So that way what happens is it will simply read the instructions in this file, the options which are there, and accordingly it will take the operating system files, it will complete the installation. This way you can perform, okay, this is called as an automated way of doing the installation. So in this process, even if you have 100 systems, okay, you can simply give a one-line instruction to all the systems and automatically the installation will get started in all the 100 systems. Clear? So this is called as a kickstart installation. Now there are different types of kickstart installations. That means they are the network-based installations. So network-based installation means, so we will see server configurations like web server or a HTTP service. Okay. So as a part of HTTP service, so we'll have access to some folders belonging to that service. So we can keep the content. Say for example, take web pages. You open a web page, right? So where do you think this web page content is coming from? So there is a HTTP or a web server somewhere on the other side of the world on a host from where it is started. So basically you are trying to access a page which is part of the web server. So inside the web server folders, under one specific folder there are some web pages. So we are trying to access that web page. Similarly, as a part of HTTP service, you can copy this kickstart file, you can copy this instruction file and the ISO source software. So you keep both of them as a part of your HTTP service. You tell the system that so my information is part of the network at this particular location. Pull them from that HTTP service, take the instructions and perform the installation. Okay. So next comes similar to NFS service, HTTP service. We have NFS service also, network file sharing, network file system. So that is another way of sharing files across the network. So you can copy the ISO and kickstart to your NFS folder or use FTP service, file transfer protocol. So even FTP service has folders. So these are all like network based services. We make use of these services in order to access the ISO file and the instruction file. So we just give the path of these services. So if it is FTP service, the path will start as like FTP colon double slash, HTTP service HTTP colon double slash, or secure HTTP HTTPS colon double slash. Okay, so we give that path to the Kickstart installer and say that you fetch this and perform the installation. So rather than doing it manually, we give clear guidelines on how to do the installation and it will do the installation for you. So that is called as automated installation process. Okay, we'll see how to do it later, but for now I wanted to have an understanding that okay, so these are the types of installations: graphical, non-graphical, and there is another category called manual or attended or unattended installation. So that is an automated installation, also called as kickstart installation. Again, kickstart installation can be done in multiple ways, like making use of the network services. You can do it using NFS or HTTP or FTP, where we only need two things. One is the software, that is ISO file. Another one is the instructions file. It is called as the kickstart file. Where is it available? So you need to do the installation on one system manually, then automatically this file will get generated. So if you want, you can make changes inside the kickstart file. There is also a kickstart file generator tool. Okay, I will show that tool. It will open only in the graphical mode, not in non-graphical mode. So using that tool also we can generate a kickstart file. It's like whatever options that we have chosen now, it will also display the same options, but there we are not doing any installation. We are simply choosing the options and it will generate a kickstart file for you. So like that we can customize our requirements using that tool or using the kickstart file, and then we will be making use of that file. That is the second requirement. Use that file in order to do the network based installation. Okay, so that's pretty much about the installation process. If you have any questions, you can ask me. I will send you the document also that would have the screenshots, but all this information will not be there. Okay, now we will proceed to the next topic. So we have seen the architecture part yesterday. Okay, the booting process. So as a part of first module, I do explain all these core concepts. So the process will be a bit slow during the initial classes, but I want you to focus and be familiar with all these topics and also with some of the basic commands. Gradually we will increase the pace. There will be a lot of commands that we'll be learning on day to day. Okay, on every day, since we're going to have classes every day, there will be a lot of topics and commands that you have to practice and be familiar with. So I hope you are ready for the practice sessions as well. Okay, so next we will move to the Linux booting process topic. Okay, so just give me a minute. I'm gonna pause for 1 minute and we'll resume. Alright everyone, so let's proceed with the booting process. So the Linux booting process, so if you are a Linux admin or if you are someone who is working on a Linux system, Linux booting process basically helps you in order to have an understanding of all the steps the system follows, okay, before showing you the login prompt or the login screen. Okay, so generally we power on the system. Okay, so what happens is the raw power will be given as an input to SMPS. So there is something called SMPS in your computer. Okay, so inside that CPU box, so it converts AC to DC, and the DC is given as DC current. Okay, that is given as an input to all the devices which are connected to your motherboard. So the moment all the devices get the power, so one of the device which is your CPU, okay, it will start taking initiation. So it is the first device that would respond. Okay, so what it will do is it will perform uh, the first step called as BIOS, which means basic input output system. So as a part of this stage, what it will do is it will quickly check whether all the devices on your system are responding or not. Okay. All right. So once so this is called as the post operation, or post means power on self test. So every time you shut down your system, right? So all the devices that are connected to the system, so there will be a list that is taken, and every time you start, so during the post operation, it will check whether all these devices are present or not, whether they are responding or not. Okay, so then the control will be given to the first boot device, so which is called as master boot record. So the master boot record, usually it is present on so even your hard disk, it is like we have partitions. Again, each partition is split into sectors. Okay, it's like the next level of block or a unit on your partition, and it is considered that MBR is present on the first partition, first sector. Okay, so first few bytes of the disk contain the master boot record. Usually, when doing so, if you want to what do you say, perform an installation using a CD drive. Okay, so we usually go to the BIOS. What is that? So we usually go to I forgot that name. So we change the first boot device, right? So we make it from hard disk to the DVD. Okay. Then when we restart your system, the system will perform the installation process using the DVD. Okay. If you don't choose that, it will try to start normally by reading the files on your hard disk. So the difference is, so we are basically asking the system to identify the MBR either from hard disk or identify the MBR from the DVD drive. So that is what would help you to initialize the process of installing the DVD or starting your operating system from your hard disk. Okay, so that's where we choose the boot device. We could use the order also, like first CD or DVD. If it is not there, then try to start from read files from the hard disk, like that. So what MBR does here is, so master boot record will occupy a space of 512 MB. Okay, out of 512 MB, 64 MB of space is occupied by the partition table. So partition table means it will contain information about the partitions present in the system. Okay, uh, so post the installation, so now that partitions that we have created, right, those partition information will go to the partition table. So it is 64 bytes in size. That means uh, four primary partitions can be part of the partition table. So we have primary partition, we have extended partition. Okay, uh, system initialization can only happen from a primary partition. Okay, so we have some limitations on MBR, that it can accommodate a maximum of four primary partitions. Each partition takes 16 MB of size. Okay, so we can have only four primary partitions. So either you go with four primary partitions or create three primary and one extended partition. So extended partition is like a logical partition. So we'll go through this information later. So this is one part of your MBR, and it also has a magic number, which is like an identification. Okay, and then it has some program code. So it will execute the program code and it will switch to the second stage of uh, the bootloader. So bootloader, so MBR is master boot record. That is the first stage, bootloading stage, bootloader stage, and the second stage is called as grub. Grub is mainly for Linux systems. Okay, so grub means Grand Unified bootloader. Here there is a spelling mistake. So it will go to the grub stage. So it is till the grub stage, you just have to remember it. From the grub stage, you can visualize the things. Okay, so grub basically what it does is it will load the kernel into the memory. So we will stop here and then we'll try to see the grub stage now. So when you start your Linux system, okay, your system will pause for a few seconds at some screen, and then it will continue with the startup process. That page is called as the grub page. Okay, so this one. So here, what we know is it will help us to choose the operating system that we have to start. You might have even seen this in with Windows as well. So if you have like dual operating systems present, initially it will pause for a second and ask the user to choose the operating system. If you don't choose anything, then one default operating system will get started, right? So the same thing happens here. So this is your grub screen where I have two kernels, okay? And remember kernel. So here I said kernel is the most important heart of the operating system, this one. So here, so this represents my operating system, okay? And the operating system in turn have these three lines. So this is if you look at the second line, it says 0.6.32. So that is the kernel. Okay, so choosing operating system is like choosing which kernel to start with. These are two different versions. C504 is one, 573 is another one. So if you are interested, there is this site called kernel.org. There you can see information about all the latest kernels that are released. So it is maintained as a different entity altogether. Okay, so now once we have reached the second stage of bootloader, what happens here? The grub will load the kernel to memory. Okay, so we are choosing the operating system here. It is nothing but we are choosing the kernel, and then this kernel will be loaded into your memory, and it will reside in your memory till the point you shut down the system. Okay, now once it gets loaded into the memory, what happens is the system will so there is another line called initRD, the third line. I hope you have observed. It is called as initial RAM file system or initial RAM disk, the third line. Okay, so what it does is it helps to create a temporary file system. Using the temporary file system, it will start the next stage where it will create partitions. It will create the actual file system. It will try to do the installation process on top of that. Okay, so initRD is a temporary file system using which the actual file system will be created and the installation process happens over there. Okay, like that, the final stage of this process is launching the login terminal, login screen to the end user. Okay, so I have given this information very briefly about the booting process, but I would definitely suggest that you go into more details of the booting process. Okay, because it is one of the interview question that would definitely be asked. So about a Linux system, so what do you know about the different stages of booting process? What happens? What is initRD? Okay, how will you identify your kernel? So this is Linux operating system is 7. CentOS 7 operating system, but kernel version is different. Kernel is 2.6.32. Okay, all right. And root HD 0, is nothing but it's the first operating system. Okay, and the corresponding partition on which the boot files are present. So the system booting happens. So you remember the boot folder that we have created post the installation process. All the files that are linked to this booting process, they will be copied to boot folder. So that's what it represents. Okay. All right. Now going to the next level. So this one, as I've mentioned yesterday, so kernel is the core or heart of the operating system. It is responsible for all kinds of things that happen, starting with allocating CPU time to all the resources in the system, and also allocating RAM to all the resources. So more or less it comes under the memory management. Okay, so process management, where it tries to handle the processes and also allocate all the resources to these processes. IO management is about input and output, taking instructions and then executing it, giving the output back to the end user or the application. IO management, disk management, handling the disks and all. So all these features, core features, are taken care by the kernel only. So that's why kernel is like the most important part of your operating system. In fact, people also refer to it like kernel itself as an operating system. So regarding the grub stage that we have just seen, so it is again, so we keep coming back to this screen because it is one of the important stage, I would say. So it is the grub stage uh, page from where it is possible to start your system in a single user mode, or you can also call it as a rescue mode. Say for example, you forgot the root password, so you go to the single user mode and you try to reset the system in a single user mode. Like that, you can also troubleshoot your system by going into the single user mode, and that is possible from the grub screen only. So from here, so if I press escape back to the first screen of the grub, press enter, the system will get started in a normal mode. But if I can edit kernel, press here, you have all the instructions. Okay, so press E to edit this one, or you can say S. Okay, which represents single user mode. Now when I say single user mode, so so it leads to another topic about different run levels in the Linux system. Okay, so different run levels means I can start my system in maintenance mode. So that mode itself is termed as a run level. Okay, graphical mode. I'm going to start my system in a graphical mode. It is called as one run level. I've showed you yesterday starting my system in a non-graphical mode. Okay, so that is one run level. You start your system. So starting your system is one run level. Shutting down your system corresponds to one run level. Like that, we have different run levels or different modes in which we start our system. Okay, so run level 1 is called as a single user mode or a maintenance mode. Okay, so we'll see more about all these run levels. Okay, so for now, so so that is just to remember the importance of the grub screen. So I have explained that. So there are minor changes with respect to this grub concept from CentOS 6 to CentOS 7. Okay, since still organizations are making use of CentOS 6, we'll focus on the 6 part. Then I will give you the differences between 7 also. So that is how we go through all the topics, and wherever necessary, I'll explain that at that time. Okay, now we'll start the system and go through some of the basic commands. Any questions, guys? Any questions so far? Are you clear on what about the topics that we have covered? Let me know if you find the pace, if it is too slow or too fast. So I'm skipping some of these slides which are a little advanced about the grub. We'll come back to these topics later. Okay. Okay. I hope you're following my screen. So I have just used some commands. I have logged into the system. I have given username, password. So this is a non-graphical mode. So even if I start my system in a graphical mode, I would be showing these things to you. So / is, imagine that this is like my computer. Okay. So under / I just ran the command called pwd, present working directory. Okay. So ls means list the contents of this folder. So you can also see the / here. Okay. This is called as the command prompt. In non-graphical mode, you would only see a command prompt. Okay. So what the command prompt says, first of all, who am I? If I switch to a different user, so the user details will be here. See, root. Now I have means I have switched to a different user. Okay, it's not like Windows click on log out, come out, log in as a different user. No, just one command, you will become a different user. Okay, so initially I was root, now I am a different non-root account. Again exit back to root user. So if you observe here, this is the username at Red Hat 6 is the host name. Host name is also a command. Okay, so host name Red Hat 6.7vm.com. So it will give, as I've said, this is the domain. So this is the actual host name that is displayed here, and this shows the location where I am. Say for example, I go to one of the directory. So it has updated the folder where I am currently. Okay. So going back, cd /. So cd is a command to change the directory. So / is the topmost folder. Under /, as you can see, there are a lot of subfolders here. So your complete operating system is spread across all these files and folders. Okay, we'll see the importance of each of these directories. So under /, also called root directory, the top level directory in the Linux file system. Okay, so some of the folders, starting with, if you take boot. So for boot, what we did, we have created a separate partition altogether for the boot directory. Now, what does boot folder contain? Let us go to /boot, cd, change directory, and always remember you need to give the path right from the top. So you can't just say cd boot, because you need to give the path wherever boot folder is. So you need to go in an order. You need to provide the absolute path to it. Now ls list the contents of that directory. So ls boot, here you can see there is a folder called as grub. So other than grub, we have files like initramfs, initial RAM file system or the temporary file system, and then we also have initrd, init RAM disk. We have vmlinux, so that is our kernel. So here you can see two different copies of each of these software. Okay, so if you remember, when I have chosen the boot folder size, I said max 100 MB is sufficient for these files, but there can be other files that will be copied to this. That's why we'll use 500 MB, right? So other files means in the architecture page, you remember the kernel over there, right? The layer of the kernel. So other than kernel, we have other things, other utilities and all present in the system. So it is possible to have two different or okay, take two different versions of kernel. That means version 2.6.32 is one version of the kernel. Here you can see that 32-504, and there is another kernel version that is recently released, that is 32-573. So I can have both the kernels copied and available in my system. So when I'm starting my computer or my Linux system, I can choose which kernel I want to start with. So installation is one. There is only one operating system, but as a part of this Linux operating system, I have two kernels. I can choose which kernel to start with. So in fact, uh, some Linux admin, okay, so say for example there is a latest kernel available, okay, latest kernel is different, latest version of Linux operating system or Red Hat or CentOS operating system is different, okay. So if a latest kernel is available, so kernel plus utilities and all the other applications will form your complete operating system. But kernel is developed as a single entity. So if you, for example, the latest kernel is released, what we can do is we can check the compatibility of that kernel with the existing applications. Say for example, you are running an organization, there are a lot of applications which are successfully running on the current version of the kernel, but you can't just stick to the same kernel all the time. So latest kernel has been released with a lot of features, but you need to check whether the kernel is compatible with the existing applications or not. So what you do, you install that kernel in your system, and when you are starting your system, rather than choosing the old kernel, choose the new kernel. Okay, so it's almost like a pluggable component to the entire picture. So remove the kernel, that means choose which kernel you want to start with. So if you choose the latest kernel and start your system, you can get to see how things are. You can test your applications whether they are behaving the previous way or not. So that is how kernel testing is usually performed. Okay, so it is possible. So that's why I mentioned the website name kernel.org. In fact, we not have to go there, but directly install the latest version using some commands also. Okay, so that's like one of the job category, testing the kernel feature, or not. So the same concept is applicable for any software, right? So even if you have using one version of Java, you develop some application, a new version has come. So it is quite common that you test the functionality of how an application behaves by making use of the latest software. So the same concept is applicable here. So your boot folder basically it would contain the different versions of kernel and the grub folder which is there. So this is what I said is different. So this folder would change. The contents of this folder would change a bit from CentOS 6 to CentOS 7. But I'll tell you, with respect to grub, you need to understand the importance of it, the stages of it, and any changes. So there are some config changes that we will do. You need to stick to those changes. That is more than sufficient. So this is CentOS 6, as you can see. So there is a grub.conf file. So this grub.conf file is nothing but the same grub page that we have seen when starting the system. Here you can see. So the default uh, page, the grub page has two lines, right? Starting with CentOS. So those two lines are here. You can see each line is like a it has a drop down. Okay, so two CentOS lines that we have seen. Each line again will have root hd comma 0 comma 0 kernel init.rd, and again second line hd 0 comma 0 kernel init.rd. Okay, so these are the two lines. See, title CentOS 573 504. So these are the two lines which we have seen. If you press edit the line, you will see three more lines. Again, three more lines. Okay, and this is called as hidden menu. So it will only display this first. You need to press E in order to check the menu. So splash image, that screen itself is an image. Okay, inside that image we have a hidden menu. So this file represents that grub screen image. Time mode is equal to 5 means the system will halt for 5 seconds at the grub page for the user input. If the user doesn't give any input, it will start with the default operating system. Default means, here you can see default is equal to 0. That means, say if you have 3 operating systems, there in the grub screen it will display all the 3, and from the top the order is 0, 1, 2. Okay, so in this file we can choose the default one. Say for example, first is Linux, second is Windows XP, third is Windows 7. Okay, so their order is 0, 1, 2. So here in this configuration file, if I change 0 to say 2, then the third operating system will start by default. Okay, so that is the importance of this configuration file. So here what I will do is I come here, press I change it to 2, save, and I'll come out. So next time if I start my operating system, it will read this default number and it will start automatically. Okay, now this steps which you are seeing now, so this is one configuration file related to grub. Like that, there will be lot of configuration files. So throughout the course, we will go through the configuration file, we will see the importance of the lines and what changes have to be made and the impact that it will make. The course is all about commands, making changes to configuration files, understanding the concepts. Okay, back. Now we are here, /ls, we have seen the importance of boot folder. Now next one is home, cd/home. So home folder, home directory contains 3 more directories. One is Arun, Kumar, ABC. So in a Linux system we have root user, rest all non-root users. Okay, and then we have third category called as system users. System users means we do not log in by making use of those accounts. So there are some services that will run in the system. Okay, so those services prefer to have their own accounts. Okay, in order to run the service, that service will be run on the name of that user. Okay, for example, I think Oracle software, if you install it, okay, it will create an account, a user called as Oracle, and when you start the Oracle database, it will run with the name of Oracle user. So that is the account which we do not use, and the system automatically makes use of those users. They are called as system users. Okay, so other than system user, we have only two, root and non-root. So any non-root user, when you create the user in the system, okay, let me show. You can see here, right? So for now, just skip the command that I'm using. You need not have to remember that. We'll see those commands later again in the user administration course. So I said user add, okay, and Ramesh. So I've created a user now. So whenever you create a user for the first time, so the user will be given a home directory. Okay, that means if I switch as the user called Ramesh, so by default I will be landed in my home directory. Now I'm Ramesh, I'm in my home directory. The first time you log into your system, if it is Windows, okay, if you start your system in a graphical mode, you will see your desktop and the location is C users Saran desktop. So that is the location where you land up, right? If it is non-graphical mode in Linux, even in graphical mode in Linux system also, you will end up on the desktop screen. Path is /home users, I mean say for example Saran, /desktop. So that is the screen you will see. Whereas in a non-graphical mode like this, you will end up in /home Ramesh. If it is a root user, as I said is an admin account. He has special privileges. So a root user will have a separate home directory. Non-root users always have a common location, which is /home with the username. You can see the folder. Whereas for the root user, /root is the home directory of root user. As a root, when I log into my system, so root user will end up in that particular folder. So these are all the files which are part of the user called as root. So root user, so every user, it's like their home. Okay, so they can do anything in their home directories. Okay, so a root user has access to every file in a Linux system. Anything, he can do anything. Okay, one command you can delete the entire system, whereas a non-root user has only access to the contents of his home directory only. Okay, so if you take the same example, so I'm in my home directory, I'm user Ramesh ls. So this is my home directory. I can create files here, I can do anything here. But say for example, as a user Ramesh, I tried to switch to a root directory. Permission is not denied. Permission is denied. Now we will try to go to boot. Okay, you try creating something. So touch is the command to create a file. Permission denied. So as a non-root user, you will not be given permission to do anything in the system. Okay, so that is your home directory. Again, back to /ls. Now, till now you have seen me executing commands in Linux system, right? I did ls, I did cd command, I ran hostname. So what are all these commands? So what exactly is a command? A command is a binary executable. Okay, so in order to understand this, you need to use another command called as file. Okay, so okay, sorry. So you can use this command called varies. Okay, so I'm running this command called ls, but I want to know whether it is a physical file that is getting executed. So I did varies ls. It has given a path called as /bin /ls. So under the bin folder, the name itself says bin contains binaries. Okay, binary executables. So now we use the command called file on bin ls. So this is just, the system will tell you what it is about. Okay, so when I'm running a command called ls, in the background what is happening, it is going to a folder called bin, which contains the file called ls, and it is executing this file. Okay, and the functionality of this binary executable is it will check the contents of the current folder and it will list the contents to you. Okay, so this is how every command works. When you are running a command, okay, as long as the command, so wherever the command is, so command, there is a binary executable file corresponding to the command, and this file will be present in one of the bin directories. There are multiple bin folders, and so that it will go and fetch that file and it will execute it, and the output will be displayed on the screen. So these commands are called as binary executables. Okay, they are present in the bin folder. That is the importance of bin folder. Okay, so then we have another folder called etc. So etc folder corresponds to the configuration files in the system. Now we have seen one config file already, that is grub.conf. So I would say that is the only configuration file present outside of etc folder. So this is your etc folder. So grub.conf is the only config file present outside. Rest of the system config files, every config file will be part of etc folder only. Okay, we'll take one example to see that. So vi etc sysconfig network hyphen scripts if cfg hyphen eth0 is your network Ethernet interface. Okay, so or your network adapter, which I said when you assign IP address to the network adapter, right? So ETH0 represents your network adapter, this particular file. So inside this file, whatever IP address configuration we have done, it is present here. So the IP address, subnet, gateway, right? So this information here, it says on boot is equal to yes. So by default, when you perform the installation, it will say on boot is equal to no. You have to change it to yes. Okay, and so that would help you in order to have your Ethernet network device up and running. If you restart your system, along with the system processes, your network interface will also get started, and your IP address will be up and run. I mean, IP address is available for you. You can communicate with other devices in the network. But if it is no, then you have to manually, enable the interface, the network service. Then, so these are available by default. The important ones are IP address, subnet mask, gateway, okay, and on boot. Boot proto is equal to none. If it is DHCP, that means you are making your system as a DHCP client. It will fetch the IP address automatically. None means you are manually assigning the IP address. This is your Ethernet device. So this is one configuration file. If you want to change your IP address, you have to make change in this file. Come here, change 125 to 150 for example, then you need to restart your network service. Then it will reread the configuration file, and then it will display the new IP address. Okay, that is network service. So corresponding configuration file is present in under etc. Like that, all config files are present under etc folder. Again, what else we have? Bin boot /dev. Dev means device related files are present under /dev. So when I say device related files, I mean now we have a hard disk, right? And we have identified our hard disk as SDA, and there are partitions on the hard disk like SDA1, SDA2, SDA3. Every device is identified as a file in the Linux system. Okay, let me go to cd/dev ls, and yeah, you can see here SDA, SDA1, SDA2, SDA3. In Linux system, everything is a file. All the devices are also identified as files. So now I'm storing some content on my hard disk. That means I'm interacting with the corresponding file. So if I'm storing something in under the boot folder is linked to SDA1. So I'm interacting with SDA1. Okay. Similarly, rest of the file system is on SDA2. So if I'm storing something in any of the other folders or the directories, that means indirectly I'm interacting with a file called SDA2. So even the network related files, now we have a network adapter that will have a corresponding file that I'll be interacting with. Okay, so this console which I have opened, it is there is a file corresponding to this console. In graphical mode, I have opened multiple terminals yesterday, right? So here you can see TTY, it is called as terminal type. It represents those terminals. I can open a lot of terminals in a Linux system. So everything is a file in the Linux system. You would only be interacting with all these files. Okay, there are only different types of files in a Linux system. So if you remember the command that we have used, command called file. Okay, file itself is the name of command. You can use this command to identify the different types of files. For example, file space err.log. it says this is ASCII text, a text file. Okay, and then say file, I have something called script.pl. It says it is a Perl script. Okay, file ASCII text, and then file /dev fda. It is a block special file. File it is a directory. See, even I can give a folder as an input to file. It says that it is a, that means even directories are also files. We have only different kinds of files in the Linux system. Okay, everything is a file in the Linux system. It could be a text file, it could be a binary executable, it could be a block file. So block file means where data transfer happens in terms of blocks. So that is how we store the data on a disk. Okay, so that's why it is called as a block file. And then we have another file called as character file. Character file means your terminal file, TTY file, which is there. It is called as character by character because we type character by character on the keyboard. So that is how the input is to that file. That is how the interaction happens with that file. That is why it is called as the character special file. Like that, we have different types of files in a Linux system, but everything is a file, and /dev directory mainly contains device files. etc directory contains configuration files. By now, I hope you have got some idea on how the Linux file system is distributed. So if you go to / and you pick any directory, so that directory is like a generalized version of a type of file, right? So boot folder has all the boot related content, bootable files, that is a separate partition altogether. etc all configuration files, home all the home directories of the users, and then /dev device related files, and then etc configuration files. Similarly, we have a folder called proc, PROC. Okay, it contains all the process related files. So there are a lot of processes running in Linux system. So you can run top command called top, and you can see these are all the processes. Okay, and information about all these processes is present under a folder called proc. In fact, the name of the folder itself will give you a hint about the information that is part of that folder. Okay, so here what happens, every time you run a process, okay, there will be a directory created under /proc with the corresponding process ID. So here you can see when you run a top command, so these are the processes, and every process will have a process ID. Okay, so with this particular number, a folder will be created under /proc, and that folder will contain information about this process. That means how much of memory this process is using, what are the other resources this process is using. All that information will be stored in a folder that is created, and the name of the folder is the corresponding process ID. You take any of these numbers, okay, and we'll go to /proc, say 13. We have a folder called 13 ls. So corresponding to 13, there is some process called netns. Okay, so information about netns is present in this particular folder. Clear? So, and this is dynamically generated. That means the moment I start the process called netns, the folder is created, and if I stop netns process in the system, then this folder will be removed from the system. So that is how the system will dynamically create and remove the contents from /proc directory. That is the importance of /proc. Okay, so like that we have, again back to the place. So here there are some more. There is this folder called as temp. Temp is the only folder which is shared by all the users in the system. Okay, so any user can come to temp and you can copy files to that location. So usually when we copy files from one Linux machine to another Linux machine, we copy the files usually to the temp folder. That is the importance of temp. And like bin folder, we also have sbin, we also have user bin, okay, and bin folder is also present in some of the other subfolders. So all these folders contain the binaries. So then remaining are lib and lib64. As the name says, all the library files will be copied to these folders. So whenever you are installing a software in a Linux system, okay, software is like a bundle, a package. So in that package, if there is a configuration file, then when you install the software, the config file will go to etc. If it contains library files, they will go to lib folder. If it contains any binary executables like commands that come with that software, those commands will go to bin or sbin directory. Like that, a software package bundle, when you install it, all the content will copy to the corresponding folder. Okay, so that is how the Linux file system is organized. So that is the importance of each of these directories. Okay, so with this, we'll wind up today's session. So please try to uh, go through these topics once again. Okay, these are like very basics. So from tomorrow, we'll focus on rest of the commands, and we'll mostly get started with making use of the commands from tomorrow. Okay. Any questions you have for the day? Feel free to ask me. I'm available for another few minutes. Uh, or if you want, I can repeat any of the topics that we have covered for the day. And it would be helpful if you can give a confirmation whether you have questions or you don't have questions, if you are good so far. All right, everyone. So that's all for today's class. If you don't have any other questions for the day, we can wind up the session for now. Thank you so much for attending the class. Please try to go through the topics that we have covered and be ready to learn a lot of new topics in tomorrow's session. See you again tomorrow. Have a good day. Bye.